Hey, welcome to this video. In here we're going to do a note cards review for chapter 9. Let's start with Taylor polynomial centered at x equal to a. The general formula is written this way. P sub n of x is equal to this formula. F of a plus f prime of a times x minus a over 1 factorial plus f double prime of a times x minus a to the second power over 2 factorial, and plus etc. Ultimately, we get a general term looks like this: f of nth power of a times x minus a to the nth power over n factorial. What is Maclaurin's polynomial? Maclaurin polynomial is, you can call it a division or a branch from Taylor polynomial. It is when polynomial centered at 0. So you can see that the formula that the Maclaurin polynomial has been written is exactly the same as Taylor polynomial, except the terms inside the parentheses is 0 instead of x minus c. Here are some convergence tests you have to remember to write. When the question asks you to do, you have to know how to do it. The nth term test, geometric series test, shortened as GST, telescoping series, ratio test, root test, and p-series test. Please refer to convergence test chart. You can search on Google for convergence tests to have a brief look on how each convergence test, the details you have to know. Let's take a look at integral test. Remember, the phrase is pretty important. This is when College Board will catch you on that. Sometimes you already write the formulas out correct, but the phrase that you forgot or some details about it will lose your point. So in order to prevent that, let's take a review. So for an integral test, it gives you 1 to the infinity of f of x dx. We have to first write this phrase. Let f of x is equal to a function that is positive, continuous, and decreasing on 0 to infinity. Remember, here is the close bracket. I'm not really sure College Board will catch you on that for close bracket or open bracket, but I generally prefer to write it as close bracket, so you can write it in any way. And then show correct limit notation. The other integral tests are if integral of convergence number, if integral of a function that is convergence, then the series also converges. And we can also derive a conclusion that the summation notation from 0 to infinity is greater than the integral from 1 to infinity. And if integral is diverges, then the series also diverges. Moving on to limit comparison test, known as LCT. Now let's take a look at direct comparison test, also known as DCT. So there are two situations normally. When a sub n is less than b sub n, a sub n is given and b sub n is chosen. If this is the case, then both converges. If b sub n is less than a sub n, which is given, then both diverge. Moving on to harmonic series. This is the general term for harmonic series. Remember, it's always going to be diverge because harmonic series. So whenever you're asking to write the explanation for this type of summation notation, remember to write it as this way. For the reason, you can just write because of harmonic series. If you want to be more specific, you can also write because of integral test. The integral of the summation notation from n equal to 1 to infinity of -1 raised to n plus 1 times 1 over n. This is an alternating harmonic series and always converges conditionally. So remember, the difference between the harmonic series is that it has a -1 raised to the n plus 1. Let's take a look at alternating series test, which is AST. So you have to meet these prerequisites, or you have to check those conditions before you apply the alternating series test. So first of all, is the limit as n goes to infinity of a sub n equal to 0, is that true? If it is, moving on to second condition. If a sub n plus 1 is less than or equal to a sub n, this should be true for all n. Then we can test the summation notation of n equal to 1 to infinity of absolute value of a sub n with all proper comparisons and tests. So in here, the reason that I wrote this line is sometimes you will be asked to use LCT or DCT to compare in step 3. So notice when to use what. And the fourth step is conclusion by ACT, whether it is going to be converges absolutely or converges conditionally. All of those conclusions are based on the previous steps. Alternating series and remainder theorem. Also should be careful with the phrase. Because this is an alternating series with terms decreasing in absolute value to 0, then the upper bound of the error is less than or equal to the first neglected term. So remember to put this line whenever you're asking to use the alternating series Riemann sum. An example of using the alternating series remainder theorem is approximate sum of summation notation from n equal to 1 to infinity of -1 to n plus 1 times 1 over n factorial, with an error less than 1 over 500. Remember to justify your answer. So how are we going to approach it? First of all, limit as n goes to infinity of 1 over n factorial is equal to 0. Is this true? Well, it is. Second step is 1 over n plus 1 factorial. Is that less than 1 over n factorial? This is also true because the denominator is greater than the denominator of the first term is greater than the denominator of the second term. Therefore, we can write out the terms for this formula, which is the summation notation from n equal to 1 to infinity of -1 raised to the n plus 1 power times 1 over n factorial equal to 1 minus 1/2 plus etc. And then ultimately we get a term that is 1 over 720. And this is the first term that we met, which is less than 1 over 500. Therefore, we have to justify right here. This is an alternating series with terms decreasing in absolute value to 0. Therefore, the error is less than or equal to the first neglected term. And if the question asking you to find the sum of the terms before the first neglected term, you're going to add all of those terms together and you will yield this answer at the end. Let's take a look at LaGrange remainder theorem for any non-alternating series. This is how you're going to write the LaGrange remainder theorem. So r sub n of x is less than or equal to the absolute value of the maximum of the function, which is the nth term plus 1 of z, and z in here is whatever the value between x and c. So x and c in here is x minus c raised to the n plus 1 power all over n plus 1 factorial. Here are some typical cases when finding maximum f of n plus 1 of z. For sine or cosine, the maximum of f of n plus 1 of z is equal to 1, but be careful of chain rule. So because sine and cosine, if you put it on a trig graph, you're going to notice that their maximum value will both be 1. So we don't have to really care about how close is it to be 1, whether it is 0.9999 or 0.99, we're just assuming to be 1. So that makes our calculation become more easier. For natural log of x, z is the left endpoint, because think about that graph. Natural log of x is when x has a vertical asymptote at x equal to 0, and then the right tail of the function is going to be infinity. Therefore, z is the left endpoint. For e to the x, z is the right endpoint, because think about that graph. E of x, like e to the x power is going to have a unlimited bound in the right tail, therefore it has a right endpoint. Radius of convergence. If there is no radius, then an example for it will be infinity less than 1. Well, this is definitely false. So in that case, there are no radius for the convergence. But what about the interval of convergence? So interval of convergence for the previous question will just simply be 0. And for other radius of convergence, if the radius of convergence is r equal to 1/2 and center at 0, what is the interval of convergence? This will be -1/2 to 1/2. So check using tests. Check using tests with the endpoints of the bound, because sometimes the endpoints will be close bracket, sometimes they'll be open bracket. We can only get our radius of convergence by using the center and the radius, but we cannot get the close or open bracket of the endpoints. So we have to use the test to see if which one is which. Now let's take a look at the power series. So f prime of x is equal to the summation notation from n equal to 0 to infinity of a sub n times x minus c to the n minus 1 power. And there is a derivative which check the interval, the close bracket on interval of convergence. It could be open bracket also. Power series, most of the cases it will be written like this. The integral of f of x dx is equal to the summation notation of n equal to 0 to infinity of a sub n times x minus c to the n plus 1 power over n plus 1 plus c. And this is an integral because you're going to check the open bracket on interval of convergence. It could also be close bracket, but this is just a normal case as the previous question. Now let's take a look at dBIP. Well, what is that? D stands for derivative. Check brackets. So B stands for brackets. I stands for integral. P stands for parentheses. So whenever it's a derivative, like it asking you to find a derivative, you have to check the bracket of the original function. If it asks you to find the integral, you're going to check the parentheses from the original function. Sine of x in here is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial plus etc. The general term for sine of x is -1 raised to the nth power times x to the 2n plus 1 over 2n plus 1 factorial. So write it in the summation notation way is right here. So basically you're just putting the general term for the summation notation. The cosine of x, on the other hand, is kind of similar, but it's also different. So 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, etc. The general term will be -1 raised to the n times x to the 2n over 2n factorial. E to the x is 1 plus x over 1 factorial plus x to the 2nd power over 2 factorial, etc. We get a general term as x to the n over n factorial, and this is our summation notation for e to the x. For s of infinity, this is most likely we're going to use geometric series to find the sum of the infinite terms of the summation notation. So the formula to get this easy is a sub 1 over 1 minus r. So this just represents the first term, and r represents the radius. And that's it for this video. I hope it helps you a little bit for reviewing all of those concepts and little details for Chapter 9. I know it's hard, but you can do it. Thank you so much for watching. Hope you have a great day.